Hello, welcome back. Today we're going to do a couple walkthroughs for some of the questions on your activity. So the first one I want to talk about is this one. So they want us to write the equation for this graph pictured over here. Now it's basically the graph of 1 over x, but it's been moved. And you can see it's been moved over 2 and up 1 from where it normally is, because normally these asymptotes are right on the xy axis. Okay, so this is a transformation of the graph of 1 over x. And if I type in 1 over x, it shows me the graph would be here. So how do I modify this equation so that it moves right 2 and up 1? So I'm going to do that just like I did every other equation that we've graphed this year. To move it up 1, I'm going to add 1 to the function itself, which bumps all the y values up 1. Okay, and then to move it to the right 2, I'm going to subtract 2 from the x. And it's hard to see now because it's on top of the blue line, but see how it's purplish? So I've got it landed on the right spot. Now, people always ask, Mr. Haslam, why is it going right 2 when you put a negative 2 in there? Why doesn't it go left 2? And that's because we're actually moving the y-axis, not the graph. So we're kind of bumping the axes over 2 spaces to the left by putting x minus 2. One way you can think about it is if you look right here, when I put in x equals 1, I'm actually getting the value I would have gotten if I'd put in negative 1. So if you put a positive 1 in for x into this x minus 2, you're going to get a negative 1 on the bottom. Well, that would be the same as putting a negative 1 into the function 1 over x as is. And so what that does is it has the effect as shifting all the x's to the left 2. Okay, but what that makes the graph look like it did is moving 2 to the right. So we're really shifting the axis 2 to the left, but it looks like the graph got moved 2 to the right. So it really, you could think of it either way. So just remember that it's the opposite of what you would think. X minus 2 goes to the right 2. X plus 2 would move it to the left 2. Okay, I also wanted to talk about this equation here. So how is it different? So if I type in 1 over x, we can see that the graph would be here and here. Our graph is here and here. What could we do to change it so that that ends up being our outputs? And if you think about it, we really are just flipping it over the x-axis. And as with everything else we've graphed, by putting a negative out here, it's going to change the y values that are positive to negative y values, and it'll change the negative y values to positive y values. And so it'll cause everything to flip upside down. So watch when I put a negative here. There we go. We got our graph. Now this negative, cool fact, negative on top, negative on bottom, same thing. With fractions, putting a negative on the top or a negative on the bottom doesn't really change the fact that it's negative. In fact, you could even put the negative out front. It's still the same result. So there's my answer for that one. Okay, this last graph I want to show you is a little different than the other two. It is moving, so it's been shifted over 5 and up 2 spaces. So that part should be easy to figure out. We know that's going to be 1 over x. And since it shifted right 5 spaces, I'm going to subtract 5. And then since it shifted up 2, I'm going to go plus 2. And that kind of gets in the right spot, but it's also upside down. So I can flip it by doing a negative. Okay. And that is flipped it, but there's still something wrong. And you can see here it should be going through these points, but it's actually going through these points. Okay. Now those points, if you look at the distance here, it's normally 1 space away from the asymptotes, but right now it's 3. Let's see. No. So if you look at our anchor points, normally we have an anchor point over 1 and up 1 in each direction. Yeah. So if you look at our anchor points, normally we have an anchor point here and an anchor point here, up 1 and down 1 from the asymptotes, 1 space away from the vertical asymptote. But here, So if you look at our anchor points, normally they would be right here, just one away, but the distance, it's now 3 times farther. Okay, if you look at our anchor points right here, they'd normally be here and here. These ones are 3 times farther away from the asymptote. So that means we're basically timesing this by 3. So what I'm going to do here is I'm going to times this by 3 by putting a 3 on the top. So when you times a fraction, I'm just going to do this with 1 over x, even though it's 1 over x minus 5. But when you times a fraction by a number, remember in grade school you were taught make it a fraction by doing 3 divided by 1. And then when you multiply these, you just multiply tops and bottoms. So 3 times 1 is 3. 1 times x is x. You just get 3 over x. So basically, when you multiply a fraction by a number, you're just multiplying the top by that number. And so a lot of times we'll do this little slide rule where you got 3 over x, and we just slide that fraction out in front and write 3 times 1 over x. Or in this case, we're going the other way. We're timesing this by 3. I'm just going to slide it on top and times it by that 1. And 3 times 1 is going to be 3. And so that makes my function match up. And there we go. And so this was moved to the right 5. It was moved up 2. It was flipped upside down over the asymptote. And it was made 3 times taller than it normally is. Okay, so that is how we would transform this graph. This would be the equation that would make that graph look the way it does. Okay, if you have any questions, as always, let me know.